Is there a difference in CPK when you have two very clear specification limits, or one specification limit, or sort of a wish for process centering? Let's find out. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video is directly based on José's question. He works in automotive and he's been studying CPK. Well done. And now he came across a couple of different scenarios in the factory, which if you are trying to implement or use CPK, you will probably also find these things happening. Now, what José asked is, how can I calculate, and is there a different formula for the CPK between these three scenarios? And the three scenarios are sort of the basic scenario. So we're trying to hit the nominal target, 0. Can be 1,000 also, but there is some center that we're trying to hit. We can spread to both directions, but we should be specification tolerance between +1/2 and -1/2. That second scenario, we have a unilateral tolerance. That is, we've got something like the flatness of a pane of steel, right? So if it's like that, at some point it becomes curved 1. But if it goes the other way, we don't say it curves -1, we say again it goes 1 centimeter outside of being completely straight. So there is no negative. And in fact, the ideal is to be exactly 0. So we want to be at 0. We cannot go to any minus, but we have a specification limit. We are not allowed to be off by more than 1. This, by the way, this is a very strict unilateral one, where you cannot go into minus. There are also the sort of fourth scenario, the unilateral ones, where you just have one up or one bottom limit to what you're allowed to produce. And if you have, for instance, a bottom limit, and this is very often when filling products, so almost any food product has this. If you put on the package that there is 1 liter in the pack, there should be a liter in the pack. You're allowed to put 1.2 liters in there. It's at your own expense, but you're not allowed to put 900 grams in there, right? So it's a unilateral without a very strong upper bound in this case. What José is checking, is seeing in his factory is, well, we've got this special case where there is no negative. And then there is this also basically the same case. So we cannot go into negative. And this was for putting the drill bit exactly in the middle, putting the hole exactly in the middle as an example. And here the target is to be exactly between 0 and the specification limit. Now that, I think, is an application of sort of wishing your process to be somewhere. So bear with me, because the question here was, do I need to use different formulas for that? And the answer is no. You will need to use that formula in a different way, and you need to be very careful, especially with that last option. So I really want to discuss that one as well. Now, what is that basic formula? The CPK is the smallest, the minimal of two options. Either the mean of your distribution that you measure minus the lower specification limit, or the upper specification limit minus the mean, divided by 3 standard deviations. Now, what does that mean? And then specifically that top part. It is a very difficult way, a very mathematical way to describe a pretty basic concept, and I will show you. If our distribution that we measure is a bit to the left of the center, to the left of the target, we are now going to check this distance from the lower specification limit to the center of our distribution, and from the center to the upper specification limit. which one is smaller? This one is the smaller one. So we ignore the larger half. So you always take for CPK, and this is with the K, for CP, you would not be too interested in it at all. When you do the CPK or the CMK or the PPK, that K means that you check only the smallest of the two. And that one, you then divide by 3 times the standard deviation of this curve. And CPK, PPK, they calculate the standard deviation a bit in a different way, but that I hope you know, and if not, go and check out more CPK in-depth videos. But this term here basically just says, pick the small one. Now, in that second scenario, what we almost always see when there is no negative is that the distribution will not be nice and normal. And that is because as soon as you go to the other side, there's also a distribution. So if it is just flatness, what you will often see is that the mean is actually pretty close to 0. Can be pretty close to 0 because you have as much going up as down. That's quite a common scenario. It's not always the case, but it happens quite a bit. As soon as you have the center of your drill hole is exactly on the center where you want to have it, and you can have a deviation in basically any axis, so it's not just left-right, but also it can be too much front or too much to the back, then what you see is hitting exactly the target is going to be very difficult. There's almost always some deviation, so you see that a bit from 0 you have your peak, because all of those small deviations, they add up, they make the peak there. But okay, that is a bit of background. What formula do we use? Well, this is actually pretty simple in that we only have one side. So if you ignore a bit the purely mathematical language and get back to what we're trying to check, which is which of the specifications is closest to the mean. Well, we only have one specification, so this specification is closest to the mean. That means that if it is a limit on the positive side, we always ignore this one and we always go for the upper specification limit minus the mean of your distribution. So that part determines your distance, your top part. Now, there is a bit of a trick here, because the free sigma, this is not a normal distribution. So if you take the normal standard deviation from this, it gets a little bit tricky. What I would advise you to do is just cut it off, everything lower than the mean. You cut it off and you calculate the standard deviation purely based on everything that's higher than the mean, because then you get basically that side and how much variation you have towards that side. It'll give you a better way to check. Then this third scenario. And this third scenario is, I think, the more interesting one, because we're targeting at 1/2 for some reason. Now, that means that our distribution will almost certainly also be closer to 1/2 than in the system we're targeting at 0. But if we are targeting at 1/2, why, right? That is not a specification. So we have one specification limit, which is we should be under 1. So here, the formula we will use is exactly the same as in the second scenario. We have the mean of this distribution, we have that side, we preferably use only this data to calculate the standard deviation, and we check with only the upper specification limit minus the average, what is our CPK. But here, you will probably get different targets for another reason. See, CPK-wise, absolutely the same in how you calculate them. But here, it's probably no good reason to be anywhere closer to 1. This you will see in situations that are much more like what I said with the weight example. So where it is actually beneficial for the company to be closer to the specification limit. It's cheaper, it's quicker to produce, something like that, right? Let's say that we're rolling our steel, actually de-rolling. It comes from this big spool of steel, and when you roll it through your waltzes, when you're pressing it, then it will start bent, right? Because it was on the big spindle of steel, and then you have to flatten it with rolls. Now, when you don't flatten it at all, it will be very curvy, way past the +1. So the more you flatten it out, the closer it gets to 0. But that also costs you time, money, energy to apply the pressure, things like that. So the closer you can steer towards the limit, but still not cross it, the faster and cheaper your process will be. Much like if you are filling, and you are filling 1 liter, you want to be as close to that 1 liter, but from the top, because you're not allowed to go under, and everything under is a defect, so that also costs you money. You're trying to creep up to that limit. Now, if that is what you are doing, CPK rules stay absolutely the same. The only thing is, here you definitely want to use only that right side for getting the standard deviations, and if it's sort of too difficult for you to calculate the standard deviation with half of the population, a good trick to do this is to take all those values and then take those same values and so shift them to 0, and then also take the negative of all those values and then get your standard deviation. It's sort of a trick to get it going as well, but use that because here you want to be at 0. Here your organization does not want to be at 1/2. This is just the best guess. What you need to discuss with your quality team, but also with management, the financial side, the sales side, is what CPK do you need? And it will not be 2, because that will cost us money. It will probably be 1.33, maybe 1.6, but that's already more expensive. Maybe you go for 1.5, maybe 1 is enough. So that based on that, you can decide how close the center of your process can be shifted towards this limit. And that's why for this last instance, you need to be much more careful about how to calculate the CPK. Because the next thing your company is going to do is use that information to get closer to that limit and take a certain risk, because that is going to generate money in the longer term. That will reduce material cost maybe, but if it's something like flattening a piece of steel by rolling it, and then you can roll it less or quicker, then it is energy, time. Such things are going to be saved by creeping closer to the norm. So you need to know what is going to be my target. And the target that we can get, so if we have a target of, and this is quite a common one, 1.33, that is 4 standard deviations basically. We'll get to that also in a bit. So you see, I actually start with the end. First, you can calculate what the CPK is, but it doesn't do you too much here. Here we'll do it the other way around. We know which CPK we want. Now I want to know the standard deviation of my process here. Right, so standard deviation. Let's say that we have a standard deviation of 0.2. How do we now get here? This is 0.6, and then we need to have that 4/3, Basically, what this equates to, and that's why I also, you have those standard steps of 1 and 1.33, 1, 6, 7, and then 2. This is 4 times a standard deviation, so what we need basically is 4 times this one. Our target is going to be to have 0.8 up there. Preferably less, but 8. This is, because of our standard deviation, what we have agreed on. And so what does this lead to? The upper specification limit is known. The upper specification limit is 1. So now we know that 1 minus where we center our process has to be 0.8. So that's 0.2. If in this process you have a standard deviation of 0.2 and you have decided, management decision, this is a choice. Your CPK is, especially in this case, going to be a choice. What target are we going to put for ourselves? But if you decide that we want a CPK of 1.33, then following this formula leads us to having to center the process at 0.2. If we would accept a lower CPK, then up here, for instance, if we accept 1, then top and bottom are the same, so this would also become 0.6. So we can go to 0.4. Now, probably without using the CPK rules and just getting some historical data and some defect rate history, somebody decided that 0.5 is a good target for you. But how you use CPK is to bring this discussion. What do we want? If you go into many parts of the food industry, you will see that for this filling process that I said with the 1 liter in the pack, many companies will go to roughly 1 as their target. Because staying far from that limit is also expensive. So you're also giving away material. So having to sort out a couple of light packages to reduce the overall filling content is an economically sound choice. So this really is a management choice. Now, of course, if they want to get it back to 1.5, because they want to get back to the old results, then you know what you have to do, which is to reduce the standard deviation. So make sure that the process becomes more predictable, less variability, less variance in your process, reduce that standard deviation, and you can creep closer to the specification limit. But all of these, so we've got a normal, a bilateral specification. It uses the full formula. And then the 2 with a unilateral specification, so only 1 specification limit, they immediately choose either it is a not lower than, so a lower specification limit, or it is a not more than, so an upper specification limit. You immediately choose which of these 2 terms you use, but it is always the distance between your mean and your spec, divided by 3 sigma in any case. Although for these, the best way to calculate your sigma is to only use the tail towards that side of your limit. Because that is basically what CPK wants to know. How many standard deviations of room do I have? This is a very capable process. This is not. This is about 1. This is roughly 2. And then, if you are in these situations, do know that this is a management choice, and you can use the CPK formula the other way around. Here, usually, you want to get as high a CPK as possible, but customers will demand a certain CPK. Here, usually also as high a CPK as possible. In this case, Usually, you want as low a CPK as you can get away with. And that sounds very strange, but that is the economics of doing business, taking a risk. So, Jose, I hope that this explained what you want to know to implement CPK in your factory. If it did, don't forget to hit that like button, write a comment, ask another question in the comment. You see, I take them very seriously. And for now, I wish you the best of luck implementing CPK. And as always, don't forget to enjoy the continuous improvement journey.